Hello everybody, in this lecture we will be solving 1973 IMO problem number 1. Here is a view of this problem. Point O lies on line G, here is our line, and point O on it. And we are also told that OP1, OP2, OP sub n are unit vectors such that the points P1 through Pn all lie in the same plane containing G and on one side of G. So because all these vectors are unit vectors, let's first start by drawing the unit circle around the point O, and then let's assume that all the points P lie on this side of line G. So therefore I will, and without loss of generality, I will just label the points in a counterclockwise manner. So I probably have P1, P2, and so on. P3 and we have P sub n points, so let's say P sub n minus 1. Some points might be closer to each other than some others, like this one for instance, and so on. But one thing is for sure, all these vectors are unit vectors in the sense that they measure 1 unit, right? So therefore we have a unit circle around the point O, and then we would like to prove that if n is odd, OP1, the sum of the following vectors OP1, OP2, OP sub n, their absolute value, I should say, sorry for that. So the resultant vector here, whatever it is, the size, the magnitude of that vector should be greater than or equal to 1. And as the notation here is clear, the absolute value of a vector simply represents the length of that vector. One thing that you can think is, why is this odd condition important? Well, let's just test a few things. What happens if n is equal to 1? Well, if n is equal to 1, so suppose that we have our line G, we have the point O, the unit circle, and then only a single vector on it, so that one, P sub 1. But then of course the claim will be true, because OP1, we know that OP1 is given to be a unit vector, and of course the magnitude of it will be greater than or equal to 1. So the case when n is equal to 1 is obvious. So what would go wrong with when n is even, right? So let's try to find a counterexample for the case n equals 2. So if n is equal to 2, again we have our line, the unit circle, the center of that circle O, and then let's for the sake of contradiction, how can I have two vectors whose sum somehow lies inside the circle, right? So because for the claim to be true, the sum of these vectors should be outside the unit circle. So for instance, if I get them close enough to each other, close enough to the line G in opposite directions in a sense, then I claim that I can end up somewhere inside the circle. And just for clearness purpose, consider this to be the right triangle. So consider this right triangle here. So this is our point P1, and that's the point P2. And consider also this right triangle. Let's assume that these angles, not only they are equal, but moreover we choose the points P1 and P2 such that we will get a Pythagorean triple. Namely, what I have in mind is that so this length, if I take it, say, I have in mind the 5, 12, 13 triangle. So therefore, and I need this side to be 1. So therefore, this one would be 5 over 13, and 12 over 13, and this one would be 5 over 13, and then the same thing here, 12 over 13 length, 5 over 13, of course, when I square them and so on, so you'll get 13 over 13 here as well, which is just 1. But now my claim is that, so you have another right triangle here, I add two vectors using the parallelogram technique, right? So this would probably be a 90-degree angle with the line G. I claim that this vector will end up inside the circle, therefore the length would be less than 1. And why is that the case? Well, obviously this is a direct result of vector addition. So all I need to add these two blue vectors OP1 and OP2 is to draw perpendiculars here and there. So in that sense, I'm decomposing this vector into two pieces, each one of them. So you can think of this as P2 prime, this portion of it, and this one P2 double prime, and in a similar way this one would be P1 prime, and this side would be P1 double prime. Obviously the height of each one is 5/13. When you add these two, the sum would be 10/13. So this distance here would be 10/13. And moreover, these two sides, these two, because they are in opposite direction, P1 prime, or you can say OP1 prime, plus OP2 prime is simply, and as vectors, these two would be equal to 0 because they are in opposite directions and equal magnitudes. So therefore, as they will cancel each other. And finally, we would get this point here, which is basically P1 plus P2, which is, so therefore the vector P1 plus P2, let's put it like this. I guess that's a terrible notation, but it gives you the idea. The magnitude would simply be equal to, if you agree, 10/13, 5/13 plus 5/13. So which would be 10/13, and in fact this is strictly less than 1, so giving us the desired contradiction. So so this claim is not true for even numbers, but now we can start thinking, hey, why when we add another vector, why would it force it to be outside of it, right? So it's kind of one way to think about it. N is equal to 3 is probably, so let's draw the circle, our line G and our point O inside. So when we put all of them, there are some extreme cases that we can consider. So for instance, right, so one extreme case would be to put them in 60-degree angle. So for instance, I can put it like a 30-degree angle here, 30-degree, and then this one a 90-degree angle, but it doesn't matter. So that this shape would definitely blow, and when you add them, it will blow outside the circle. When you start brainstorming, you realize that that things are not obvious. One extreme thing you can do would be this. If you so that's the point O, this is the line G. If you put one of the points P1 here and you place P3 here, and P2 is anywhere here, it's not important. The best thing you can do is you can have P1 and P2, OP1 plus OP3, sorry. These two vectors add up to 0, but still the remaining vector OP2 will have a length, OP2 have a length equal to 1, which would imply that OP1 plus OP2 plus OP3 in terms of magnitude, remember that OP1 plus OP3 we just established is equal to 0, so therefore this thing is equal to the magnitude of OP2, but this is we just showed that it is just 1, right? So as a result, this gives you an idea that this thing is definitely true. Intuitively it makes sense. So therefore I would like to prove the claim, probably using because the case work on N seems reasonable, I can probably use induction on N, So before I go on with the induction proof for the claim, I would like to remind you of two facts about vector addition. Fact 1, if you add two vectors, let's say vector A and vector B, then the addition vector A plus B would be is between, in terms of direction, between vector A and vector B. In fact, we can more precisely say exactly where that vector B using the parallelogram technique, I guess that everybody is very well aware of. So that's the first fact that I would like to remind everybody. And the second fact, which is slightly more technical, is that if again you have two vectors A and B, and if also the angle between the two vectors, let's call it theta, if that angle is also less than or equal to 90 degrees, then the claim is that the sum vector, this one again, this vector, the sum of these two vectors in magnitude would be greater than or equal to the magnitude of any of these two vectors. So for the second part, I can provide a very short proof, if you will, using the dot product definition for absolute values. So here it goes. So if you look at the square of the expression on the left hand side, so this is a proof. So this, by the dot product definition, would simply be the dot product of these two vectors. And now when I expand it, that would be a dot a plus b dot b plus a dot b plus b dot a. So because it's commutative operation, a dot b, two of them. And finally, remember the vector multiplication. It would be actually pretty clear here when we handle this one. Let me start with that one actually. It would be the size of angle vector A, size of vector B times the cosine of the angle between the two. So it was theta here. And because these two vectors, when we multiply vector A and with vector A, it would be the size of A times the size of A times cosine of theta. Cosine of 0 degrees is just 1. So therefore we would get a square here and then a b squared here. But then it is obvious that the left hand side, namely this expression here, is greater than or equal to, notice that when the angle is less than or equal to 90 degrees, this one is greater than or equal to 0. As a result, the whole thing is greater than or equal to 0. As such, the left hand side should be greater, and both of these are strictly or greater than or equal to 0. It would be more than, greater than both components. And that finishes the proof of the second fact as well. Now we can go ahead and use induction on n. So use induction on n. We have already showed the base case. For the base case, when n is equal to 1, obviously there's only a single vector, OP1, and that vector we already know has a size exactly equal to 1 because it's on the unit circle around the point O. But then of course this would imply that OP1 is greater than or equal to 1, right? So therefore the conclusion follows. Now using induction, let's assume that so this is our our induction step. So what we have is, suppose that it holds true, so the statement, the claim, this claim namely, given at the beginning of the problem, suppose that this claim holds true for all odd numbers n less than n. So therefore because n is odd, because n odd, let's say, because n is odd, suppose claim true for n minus 2 odd, then we need to show that it must also be true for n odd, right? So consider, let's assume that those n minus 2 odd points are namely P2, P3, and so on, P sub n minus 1, and I'm going to add two new points here, P1 and Pn, and see what happens. But first of all, because the claim is true for n minus 2, it implies that the sum of all these vectors, well, okay, so let's write that down. So we know that OP2 plus OP3 and so on, all the way up to OP sub n minus 1, this sum is inside, somewhere inside the unit circle, right? So therefore consider the following picture. Again, we have our unit circle, the line G, the point O, and then on that unit circle we have the vectors P sub 2 and so on, P sub 3, OP1, OP2, OP3, and so on, and finally OP n minus 1. And then obviously I I have excluded, or let me actually draw them with different colors. Let's say that this is P1 and this one is P sub n. Well, first of all, using fact 1, we know that this vector here is somewhere between vector point P2 and P sub n minus 1 on that arc or beyond that, right? So it is somewhere here. So you have a vector which is the least it has a size like this, 1. The least size that it can get is 1, and it is definitely inside between OP2 and OP sub n minus 1 because of fact 1, right? So this vector between let's say the angle between OP1 and OPn minus 1, so between these two vectors. And now we want to see what happens to the sum, to the whole sum, right? But first consider this sum, OP1 plus O sub P sub n. So this sum is also between P1 and Pn. In fact, because both OP1 and OPn, they measure 1 unit, it would be on the angle bisector, because I will draw a parallelogram, right? So once I draw the parallelogram, maybe I should draw it with a different color. So here, so that would be my that vector here. So this is OP1 plus OPn, and this one here is the sum of all the others. In fact, let's call this vector as U. So this is vector U, and let's call this sum as W, vector W. So this one, and this way I don't have to write all this stuff. Okay, but then this is an angle bisector here, right? So we agreed on that. So these two angles are equal. But then this angle, so notice that angle P1OPn is less than or equal to 180 degrees because all the points are on one side of G. Even when P1 and Pn are on G on opposite ends, nothing would change. But then what happens is that the angle between, so let's say the angle between vector U and vector W as a result has to be less than or equal to 90 degrees, right? Because you have W, which is exactly in the middle of this angle P1OPn, and then you have also sorry for that, this one is a P2 here, and then you have the vector U, which is between P2OPn minus 1, that angle. But if it's between this angle, then it is definitely between OP1 and OPn as well. So therefore, vector U and vector W are very close to each other. But then vector U is at least greater than or equal to 1, as we noticed earlier, because it works by our induction thing, right? So knowing that this is greater than or equal to 1 at least, it must imply, so combining all these, this implies that W plus U would be greater than or equal to U, which is greater than or equal to 1. Well, the size of it, sorry for that. And that's it. And we have just proven that, and obviously W plus U, so therefore W plus U, which is simply equal to OP1 plus OP2 all the way up to OPn minus 1 plus OPn. Notice here that the middle part here is simply the vector U, and these two here, the first and the last guy, is W. So therefore this will give us W plus U, but this implies that the size of all this has to be greater than or equal to U, which is greater than or equal to 1. And that simply completes the desired proof, right? So therefore, it establishes the claim holds true using induction when on n, where n is an odd number. Hope you enjoyed the video and looking forward to see you guys in our next lecture.